Welcome to SQL with Python. In this seventh video, we'll be looking at subqueries and nested queries. Of course, we know it's a marriage between SQL and Python, and as a result of that, you always have to use some extra things to connect Python with the SQL database, right? Our objective in this lesson, by the end of the lesson, you'll be able to create an SQLite database using Python, define relational tables with foreign keys, insert and query data using subqueries and nested queries. Understand how correlated subqueries and scalar subqueries work. All right, so straight up, we go to setting up the SQLite database in Python. We've done that a couple of times. So, as usual, we know that SQLite is inbuilt into Python, so you don't have to install it. You don't have to install it, you just have to import, right? So as we see in line 3 here, we want to create a new SQLite database or connect to existing one. So if there was a database called company.db, then this line 4 command will just connect with it directly. Or if it doesn't exist, to create it. In most cases, it doesn't already exist. Like if you check my folder now, you see the database that I had created in the past, my database 1, my database 2, my database 3, e.g. the academy, and then shop, right? These are the databases I had created previously, right? So the company database thing is not here. So, but by the time I run this now, you see, we can come back to check that it has been created. So we create a user cursor object to execute SQL command. So since we are running SQL in Python, we always need to create a cursor object to execute SQL commands. So here we are calling the cursor cur. So cur equals con.cursor, and then we can print. So once that is done, we just print SQLite database connected successfully. So if I run this now, okay, this is the code. I run it and then so SQL database connected successfully. So we can come back here. You can see the company database has been created just on time 4:04 a.m. This is 4:04 a.m. right here. All right. So back here. So having created the database now, the next thing we want to do, we've also learned to use execute scripts. If you want to put one data at a time, you use execute. If you want to put more than one data at a time into one table, you use execute many. But if you want to impute all the data you want into more than one table at a time, you use execute script. And in this case now, together you are accessing the database through the cursor, right, which is connected to the database. So creating tables here, we want to create tables called departments, employees, and orders. So we are expanding the table now. So previously we've been working a lot with customers and orders table. Now we want to talk about departments, employees, and orders, 3 tables. So we'll use the execute script to run multiple SQL commands at once. So in this case, let me highlight. This is important. Execute script. We came across it starting from the last video on working with multiple tables. So first of all, we want to drop existing tables if they exist. And the way to do that is to avoid confusion. So drop existing tables if they exist. But if it's not your database, please don't do this. Or best thing, before you start doing anything in the database, copy the original one you have, save it, keep it safely somewhere, and then work on this and work on the another copy. So if anything goes wrong, you can always revert to that old data, that original database. But this is for teaching purposes, so I'm at liberty to always do this. So the first thing is we want to drop existing tables if they exist. So drop table if they exist. If exist orders, drop table if exist employees, drop table if exist departments. So it's more like clearing the ground to now create your own tables. Now those 3 lines are to do that. And the next thing is you want to create departments table. So of course we are used to creating already. So you remember CRUD, create, read, update, and delete. So I mean we've been doing things like that a lot, especially creating. So create table departments with ID, which is integer primary key, and the name text not null, and region is text. So then next you can create employees table. So create table employees. Now in this employees table, now we have ID, which is the integer is the primary key, name text not null, salary integer not null, department ID integer, foreign key is the department ID. So you can see there's ID in the department and there's also ID. Uh, so this is department ID is what the department ID here is the foreign key that connects with the department ID over here, right? So, and then we create a third table. So don't forget, uh, primary key here, the ID for departments table, start also is found here to connect this departments and employees table. But then we have a table for orders, right? Orders table, which also, so we also have an orders ID, which is an integer and a primary key, and we have employee ID integer, amount ID integer, created at text, and then foreign key. So the foreign key here is also employee ID. So this also can connect with the we had okay, yeah, we have employee ID here. So you see, with this employee ID now, this employee ID is now foreign key here that connects the others table with the employee table, while the department ID connects the employees table with the departments table. So you see, we have three tables now. We can connect them like that with these different IDs. So of course, don't forget to run. By running, now we create these tables automatically. All right, so these tables have been created. So tables created successfully. Now, mind you, we have the database company.db, and we have tables for departments, employees, and orders now. So the next thing we want to do is to insert data into all these things. So inserting sample data, and using execute script, we can do that in one blow. So what we just need to do is insert data into department. So you just say insert into department ID, name, region values. So one, HR Europe. Two, engineering North America. Three, sales Europe. Now you can extend it to as many as you want. You can take that up as a practice on your own. So you can keep extending the list. But the last one you end with, so each list is separated by comma, but the last one ends with semicolon, right? So insert into employees ID, name, salary, department ID, values. So you have Alice 70,000 salary, department ID is one. Two, Bob 80,000, department ID is two. So Charlie and Bob are in the same department. Alice and Eva in the same department. So only Diana is in a separate department and all that. So you can also insert data into the orders. So insert into orders. So you have ID, employee ID, amount created at values. So you have a date involved, right? So you have all these order IDs, and these are the employee IDs and the amount of for the attached to the orders. And you have one employee ordering twice and all that. So don't forget to run. Also, as far as this place is blank, you have not executed it. So I just press Control Enter now, and then it tells me sample data inserted. So we have created the database, we have created the tables, and then we have inserted data into them. Okay, so we have three departments, five employees, and five orders. All right. So now we go to the real deal, which is about subqueries and nested queries. So running subqueries. So now let's break this into types of subqueries. So we have different queries. Now, of course, as the name implies, right? We have queries. We've been using a lot of queries. Now we want to do subqueries. So the first type of query is a scalar subquery. And maybe, for instance, you want to get employees and the number of orders they made. So get employees and the number of orders they made. So that can be like some kind of subquery. So in this case now, cursor.execute, right? And then this is whatever is in red, all this one in red, the actual SQL command that you would have in an environment where you don't have to, where you don't need anything to connect, right? So here you say, so we need employees and the number of orders they made, right? So you select name. So that's like the main, this is the main query now. Under the select name now, we now do a sub query where you now start again. So once you select the name, you now select the counts, all the counts of the rows from orders, from orders where the employee ID from order is equal to employee's ID. So you are connecting the orders table with from the orders table now, you are setting a condition, right? Where the employee ID must be equal to the employee's ID in the employees table, right? So you're linking orders with employees in short. So, and we are returning that as order count from the employees table now. So watch everything that is now happening. So this is just a command to print, and then you now say for row in fetch all. So we want to fetch all possible rows that match this thing. So it means we are selecting all the employees from rows where we have employee. So we are selecting employees and the number of orders they made. In short, that's what that is about. So if you click this now, you get this. So Alice makes 2 orders, Bob makes one, Charlie makes 0, Diana makes one, Eve makes one. That's what that gives us. So now you've seen a scalar subquery. Then we can also have a subquery in from. So for instance, we need something like average salary per department. So you can use a subquery in from now. So see this. So select. So see what happened here. So this scalar subquery is a subquery under select. So, but here now you have a subquery under from, like after from, that's where the subquery comes in. So now, so here we need average salary per department. So you now have this. So call or execute. This is what helps you to connect to the database in Python. So you have select D name. So that's name from the department. Then average table dot average salary, right? So from the average table, you select the average salary, but then we didn't really have average table before. All right. Now see what's happening. So from now, you now create a subquery. That's why we say it's subquery in from. So you now from now you now select department. So you are creating a new table entirely, right? So that's why you see this average salary is coming from this average table that you're just creating here. So you now select department ID, average salary as so that average salary now you're selecting it as average salary from employees, and then you group by department ID, and then you return it as average table. All right, that's coming under from. And then so the table you now get from there now. So from this average table, you're now joining the average table with the join departments. You're not you are joining average table to join to departments rather, and you are connecting with the department ID and the department ID from the average table. In this average table now we now have this department ID. So it's a bit complicated, but you want to relax. So it's like you're creating a new table from the department. I mean, you are creating a new table in short, right? You are selecting some information and creating a new table out of it. So from that table you are creating, that is where you are now. So you are now joined with the department table. That's where you're now getting this information. So then you do. So this is just a print command in line 11. So if you want to fetch all rows that meet that requirement, because you need all the average salary per department. So that's how that goes. So we run this now, and then we have the average salary per department. So from subquery, so this is a from subquery, right? The other one was a scalar subquery, which is you have a subquery under select, right? So here now you see that HR, the average salary from HR is 72,500. The average salary from engineering is 85,000. The average salary from sales is 6,000, 60,000. I mean, you can look at the original table to confirm this, right? Where are the departments? And so okay, HR is one. So we have that is the ID now, department ID. Do we have department ID here? Yeah. So you have two people from HR here. So the average salary is 70 plus 75. That is 145. So that's why you have the average salary to be 72,500 for HR. So you see that here. So engineering is at 5,000 and sales is 60,000. Now you can also have subquery in where. So we've seen scalar subquery, which is subquery under select. We've seen subquery in from, that which is subquery under from. But now let's see subquery in where. And this can happen in this case where you need to get something like you want to get names of employees in Europe-based department. So any department that is in Europe, you want to find the employees there. All right. So from the overall table, right? So um so HR and sales are in Europe, right? Those are the two departments in Europe. So we want to get names of employees in Europe-based departments like that. And so that's going to make us get subquery in where, right? So see what happens. Of course, so you are connecting to the database now. You're selecting the name because you need employees, right? Name from employees, where department ID in. So under where now? So where department ID is, then you now select ID, all right? From departments, where the region is equal to Europe. So you get that now. So subquery in where. So under where you now give the condition, select ID from departments where region is Europe, and then you can fetch all of that. so once we do that, you see that those guys are Alice, Diana, and Eve. So those are the people in the departments in Europe, and those departments are HR and sales. And we can confirm that, right? That's Alice, Diana, Eve. Alice, Diana, Eve. Now, Alice, Diana, and Eve, they are their department IDs are Alice, Diana, and Eve. Their department IDs are 1 and 3 in short, 1 3. And if you look at 1 3, those are HR. I mean, those are HR and sales, which are both based in Europe, right? Right, so we have that. So the next thing is to talk about correlated subquery. So we can have correlated subquery. So here, for instance, if you need to find employees earning above the average in their own department. So there's a department average, you now have somebody earning above that average, right? So you can get a correlated subquery. So in this case now, again, we focus on the SQL query, starting from line 2 to line 7. So here now, employee is still the focus, right? We just want them to have uh they, they have salary above the average salary. So you select name and salary, okay. Then from employees E, this E is like is the alias that we used to do in pandas, where in Python, where we say import this as this. So when you say from employees E, so anywhere you mention E again, it will be known that it is coming from the employees table, right? So from select name and salary from employees E, where salary is greater, then under that now, you can now say is greater, then you now select average salary from employees table. So average salary of employees table, where department ID is equal to E dot department. That's department ID in employees, where the key connects department ID to the employees table again. So with that now, you are saying that the average salary from the employees table now. So any employee that earns more than the average, we want to see for each department, right? So if you fetch all this case, so you see we have correlated subquery, employees earning above department average. So Charlie earns 90K, Eve earns 75K, Charlie and Eve. So let's say Charlie and Eve from the original table, right? Charlie and Eve. So Charlie is in engineering. Okay. Okay. Yeah. Charlie and Bob are both in engineering based on their department IDs, right? So the average salary there will be 85,000, but Charlie earns 90K, which is above the 85,000 average. And then we have Diana. Diana is in sales department. By the way, she's the only person in the sales department, yes. So the average salary will be 60,000 and Diana ends that 60,000. So, oh, is it Diana that we have there? I think it's not Diana. I think it's Eve, right? Yeah, it's Charlie and Eve. Yes. So we should be focusing on Eve because for Diana, Diana does not meet that criteria. So Eve is in the Eve is in HR. Eve is in HR. 70 plus 75. So the average salary is 72.5, but Eve earns 75,000, which is ahead, which is more than the average salary for HR. So with that, we retrieved that. Then we also have what is called the exists subquery. So yeah, we can list departments that have at least one employee. So we want to know all the departments that have at least one employee. Maybe there are some departments that have nobody. So we can use the exists subquery. So here we select name from department D where it exists. So under exists, I now select one from employees E where E dot department ID equals D dot ID. All right. So select one now. So where you exist, at least you have one department that have at least one employee. So if you run this, okay, we have HR, engineering, and sales. They have I know I think engineering has just one employee. From what we saw originally. Engineering has one employee. No, not engineering. Now it's sales. Sales has just one employee, and that is Diana. All right. So, all the departments qualify because they all have staff. So if you create a longer list and then, so maybe you have a department, maybe you have marketing, and when you get to the employees table, there's no marketing is number 4, and then nobody has that 4. Then that could happen. So you now see employees that don't belong to any or department that don't have any employee, something like this. Then we can also talk about a nested query. So see how this happens. So maybe for instance, if you need top earners in departments in Europe, top earners in departments in Europe. So see how that happens. So select name and salary from employees, where department ID in. So after the in, you now select again. So select ID from departments where regional is. So you want to select all departments in Europe, and then you want to link that up with where salary is now. So and salary, so this is nested, right? So you have layers, and salary, you now select maximum salary from employees E2, where E2 dot department, where is E2 coming from? I'm trying to be sure of that. Oh yeah, from employees E2. So we had an employees E before. Now we are calling it E2. So from employees E2, where so from this employees E2 now, where E2 dot department ID is equal to employees dot department ID. So if you run this now, we get okay, we run this now and we get those. So top earners in European departments, Diana 60,000, Eve 75,000. Now let's go back to the original thing and see Diana and Eve, right? Uh, European departments in Europe are HR and sales with number 1 and 3. So for number 1, all right, HR. So the two people are in HR. Eve is the top earner there. Then sales is number 3. That it's only Diana that is there. So Diana automatically can be considered the top earner because there's nobody to compare Diana with like that. So that's how that goes. So we are done with all that. Then we can just close the connection, and database connection is closed. So once we are done getting all that information, so in summary, right, we have all this. We have scalar subquery where we can select and count. So in that case, you have under select, you have another select starting out, then subquery in from. So you have select something from. So after from, you have select coming, then you have to name it something. Then subquery in where. So that comes where ID in. Then you now start another select. So how you know you have started the subquery is when another select actually starts. Then you have for correlated subquery, you have where salary is greater than, then you now select average, whatever, average, blah blah blah. Then you have exist subquery, you now have where exist, then you start select. But nested query, you combine subqueries inside each other. Now, this may take some practice to learn because it can be a bit complicated, but with some practice, you can get things in place. So all you just need to do is just like my code sheets are always available. If you access it through the link on the description on YouTube or on Facebook, you can access all this information right there. Then try your hands, tweak things until you master these concepts, right? Tweak them until you master all of these ideas. Now, but one beautiful thing about this whole thing is that instead of using nested query, sometimes you can use your normal group by aggregate and all that and still get the same result. But I mean, it's just important to introduce ourselves to this concept. So one thing about anything that involves coding is that you can do one thing in 5 ways. So you just need to know those 5 possible ways. All right. So let me know how helpful this video is for you. And let me know if there's an idea you'd like me to try out. Feel very free. I may be able to pull it off. So if you have subscribed to the channel, thank you so much. If you have not subscribed, please go ahead and subscribe. And don't forget to hit the notification bell so you can always get alerted each time a new video is released. And don't forget also that my channel now has membership. So you can have special privileges like having access to my PDF notes uh, for math related content. You can be the first to see some content. You can also be the only person who sees some actually some content. You can have a one-on-one consultation with me depending on the level of membership you're in. But if you don't even become a member, no problem. You still have access to the videos right here. Okay. But if you want some escalated privileges, you can sign up for. I have 3 categories of membership right now, which you can take advantage of. All right. So be sure to also like and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing data right. Bye.